Hello again everyone, this is Steam Code and welcome to the fourth part in our Minesweeper tutorial series. In this part of the series we're going to be going over how we create the handler class. The handler class is essentially what's going to tie together this entire project. What the handler class will do, it's going to handle what happens when we click on the cell, what happens when we win the game, and what happens when we lose the game, meaning when we step on a mine cell. Without further ado, let's get right into it. So I've already created the handler class here, and there's not much to it. The main function of our class is going to be the click function. So let's create that function right now. So we're going to say public void click, and we're going to pass into it a cell as a parameter. Okay, now I want to explain a little bit how this is going to work. So again, as I said in some of the earlier parts, there are three different types of cells. There's going to be a type of cell that is empty, there's going to be a type of cell that has a number on it, and there's going to be a type of cell that has a mine on it. And depending on the type of cell, what happens when we click is going to be different. So we're going to add functionality for that in this function that is going to handle what happens depending on which type of cell that we're stepping onto. Okay, so the first thing we need to know is the position of our cell. So in position, we're going to set that equal to our cell dot get position. Okay. All right. Then we're going to add an if statement here that's going to handle what type of cell we're going to be clicking on. So if cell.getType equals 0, so that would be the empty cell, and we're going to have stuff in here for that. We're going to also have else if cell.getType. Let's do this 2 right here, right? And then the easiest thing to handle will be if this cell is 1, which is a mine cell. So that's going to be the easiest thing. We're just going to put that at the end of our if statements here. So if cell.getType is equal to 1, we're going to put that at the end. And we got the curly brackets here as well. Now, what we're going to be doing, I want to explain how the Minesweeper works. Essentially what happens is every time we click on an empty cell, okay, it's going to, let me pull up an example here. So every time we click on an empty cell, right, it's going to do this, right? So what the behavior of this is really is it goes from the empty cell here, and it'll look at the next cells, and it's going to keep on activating those cells until it reaches a number cell. So as you can see here, it goes all the way out until it's bordered completely by number cells. And that's essentially what we want to do here in our handler function. So this is the way we're going to do it. We're going to have 2 different array lists, and each of these array lists are going to be handling how we actually deal with each cell that is next to the empty cell that we've clicked on. So we're going to have private array list, and it's going to be made up of cells, and we're going to call it current. We're going to set that equal to a new array list. And then we're going to have a private array list that's going to be called a queue. And I'm going to explain a little bit more, and it'll make more sense as we go along what these are for. Okay. So we have our 2 array lists, and we have our if statements right here. Okay. So now what we're going to be doing is we're going to first handle the empty cells. Okay. Now, as I said earlier, the empty cells have a very special functionality, a very special behavior. And so what we're going to be doing is we're going to be essentially taking this cell, we're going to be looking at the cells adjacent to it, and we're going to be checking to see if those cells are a number cell. If they're not, then we're going to continue to keep on going as far as we can. Okay. So what we're going to do is we're going to have, now, by the way, right, we're not going to be able to just say we have one cell here in the middle, right, and then we have the 8 adjacent cells, right? Because depending on if we're in the corner or if we're on an edge, there may not be 8 adjacent cells. So we're going to add functionality to that as well. So there's going to be a lot of if statements here, but I'm going to try to make it simple so that we can understand, so that you can understand exactly what each of these mean. So the first thing we're going to handle is if the actual cell that I've clicked on is in the first row, okay? So the if statement for that is going to be if position is less than game.grid size. Okay, so that is if the position is between 0 and 9, meaning that it's in the first row. This is the functionality we're going to have for it. Okay, then we're going to have another if statement, else if the position is going to be greater or equal to game.grid size times game.grid size minus 1. Okay, now this is going to check to see if our cell is in the last row. Okay, additionally, we're going to see if our cell is in the leftmost column. So else if position, and the way we're going to check for the leftmost column is going to be using the modulo operator. So it's going to be if the position modulo game.grid size, if it is equal to 0, that's going to reflect the behavior of it being in the leftmost column. And similarly, we're going to check in the rightmost column if the position modulo game.grid size is equal to game.grid, and I think I have a typo here, game.grid size minus 1. Okay. Take that out there. All right. Now, within each of these if statements, we're going to have a small branch of if statements as well. Okay, so let's deal with this first. All right. So if position modulo game.grid size is equal to 0. So this would be if it's in the topmost left-hand corner. So top left corner. Then what we're going to do is we're going to add the adjacent cells to our queue, which is the queue is what's going to aid in handling the cells that are adjacent to the ones we're looking at. So we're going to say queue dot add grid dot cell grid dot get, and we're going to get the position of, first we're going to get the position of the cell to the bottom, which would be position plus game.grid size. Okay. We're also going to add grid.cellGrid, and we can just copy and paste a lot of this because we're not going to be doing much to change a lot of this code. This is going to be the cell that is going to be to the bottom right of the cell that we're looking at. And then we're going to add the cell to the direct right of our cell, which would just be position plus 1. Okay. So this is looking to all the cells that are adjacent to the cell that's at the top left, right? That's what we're going to get to once we're in this cell, or once we're in this if statement here. Additionally, right, we're going to add functionality for if the cell is on the rightmost corner on the top row of our cell grid. So if position is modulo game dot grid size is equal to game dot grid size minus 1, right? So that'll be if the cell is at the top right corner. We're going to do very much similar to what we did here, except we're going to change a little bit of the numbers around, okay? So we're going to still do the cell to the bottom, but instead of the cell to the right, since it's on the top right, there's not going to be a cell here. We're going to have to change this to -1, which will be to the cell to the bottom left of the cell that we're looking at the top right corner, and also the one to the left of the corner cell over here. Now, all else will just be the cells on the top row that are not in the corners, and we're going to add to the queue all of the cells adjacent to it. So there are going to be 5 cells in total that are adjacent. So we're going to add this cell first. So that's going to be the one to the bottom. Then we're going to add the one to the bottom right. Then we're going to duplicate this. We're going to add the cell to the bottom left of that current cell. Then we're going to add the cell that is to the right. And then we're going to add the cell that is to the left of the cell that we're looking at. So this is the entire top row of cells, okay? So essentially what we're doing here is we're taking the cells that are adjacent to the current cell that we've clicked on, and it depends on where the cell is, and we're going to add that to our queue, right? Which is we're going to iterate through our queue and our current array list to look at all the cells that are adjacent to the ones that we've looked at already, okay? Again, right, with this example, we're looking at the cells adjacent, and so that until we reach a number cell, we're going to keep on searching and discovering cells that are adjacent to the one we clicked on, okay? Now we're going to add functionality to the cells that are on the bottom rung or the bottom row of our grid. So let's just copy this here, because the code is going to be very similar to what we have on the other section. So if it's on the bottom left corner, okay, we're going to do a very much similar, but instead of plus, we're going to take a minus, which means that it's going to be on top. We're going to do minus over here, and then to the right here. That's good. Then this is going to handle if it's on the bottom right corner instead of plus again, right? We can't do plus, right? Because plus would be the one to the bottom of the current cell. We're on the bottom row already, so there's not going to be a cell that's more below than what we have here. So we're going to change that to a minus. We're going to change that to a minus, and everything else we can leave. Again, over here, we're going to change this to a minus. We're going to change this to a minus, and this to a minus, okay? Now we're going to deal with the cells that are on the leftmost side of on the leftmost column of our grid here. So over here, we're just going to use the queue add function here. Okay. Now, what we're going to do here is we're going to do very similar. We're just going to take position minus game.grid size, the one to the top. We're going to take the one to the bottom of us here. We're going to take the one to the top right of us. And we're going to take the one that is to the bottom right. So take that plus, like that. And we're going to take the one to the right of us. So these are the 5 cells that are going to be adjacent to any cell that's on the leftmost position. Now keep in mind, we already handled the corners in this if statement here, right? We handled the corners over here, and we handled the corners over here. So we don't need to worry about the corners in this if statement, because this precedes this right here. And then we have functionality for the cells that are in the rightmost. Okay. And again, it's going to be very similar here. is going to be minus, right? So the row above us, the row below us, but then we're going to change these to minuses here. So these are going to be to the left of the one that we're looking at. And then we're going to change this also to a minus. And then we're going to have all else situations, right? We're just going to check every cell to adjacent to us. So there's going to be a total of 8 cells that are adjacent to us if we're for anywhere in the middle of our grid here. So let me just copy this again. We're going to just be changing this like before, slightly to accommodate what we have. So this is going to stay the same, right? Again, to the bottom, to the top. And then we're going to have, again, this is going to be to the top left of us. This is going to be to the top right or to the bottom left of us. And then we're going to add to the bottom right and to the bottom left, or to the top right and to the bottom right. So we're going to change this to a plus, and we're going to change this to a plus. And then also, in addition to checking for our left side, we're going to check for our right side as well. Okay. So this has all the code that we need to check for the ones that are next to us. Now, when it comes to actually iterating through each of these cells now. So now we have our queue array list all populated now after we go through this entire thing. So what we're going to do now is we're going to add some of our for loops here. So essentially we're going to iterate through our queue array list. We're going to say as long as x is less than q.size, we're going to iterate through. Now, if our current cell if it's not been discovered yet, then we're going to add it to our current array list. Now the reason we have, okay, let me just finish writing this here. The reason we have 2 different array lists is because our queue is just going to populate, okay, any cell that is adjacent, okay, to the one that we're looking at. But that cell that's adjacent may or may not have already been checked. So the queue is just going to populate it, and then the current array list is what's we're actually going to look at to actually handle, right? So everything that's in queue may not make it into the current array list, right? But we need it to function this way so that we are able to look at all of the things into queue and then put them into current. This is the most efficient way to do it. And then after we put the cell into the current array list, we're going to set that discovered to true. This will also help us to make sure that we do not duplicate any of our things here, anything that's in current, right? Because we don't want to duplicate it. If we duplicate it, we're going to end up running into errors in the future. Then we're going to clear our queue for the next time we run through it. Okay. Then also we're going to add our functionality for checking our actual cells here. So while current isn't empty, so while not current is empty, we're going to do this. We're going to do the following. So we're going to set a temporary cell. We're going to assign it the variable temp, and we're going to assign it to current dot get 0. So that's the first item in our current array list. We're going to remove it so we don't end up accidentally iterating through it over and over again, because that'll put us into an infinite loop. So we're going to remove that. And since we still have it as a temporary variable, we can work with our temporary variable now and just say temp dot click button. All right, so this is essentially going to run right through this entire code again, and it's going to populate our entire our list until we have found every cell that's adjacent, that until it borders with a number cell. Okay. Now, additionally, we're going to add functionality to our number cells and our mine cells. These are going to be a little bit easier to handle. The number cells are easier than the 0, right? We don't have to have all of this. And then the 1 with the mine cells are going to be the easiest to handle. So before we do that, let me just make sure we have some other functionality here at the beginning. So we want to say if hold on. We're going to say cell dot set enabled. We're going to set that to true or so false. And then we're going to set cell dot set discovered. We're going to set that to true. Okay. So essentially we're going to enable, or we're going to set that button to be enabled. We're going to set it to false, and then we're going to have our own variable which is set discovered. We're going to set that to true. So any cell that goes through this thing here, this function, is going to be set to discovered. We have discovered that cell, meaning that we have knowledge of what the cell actually is. Okay. Now, when it comes to the number cells, the functionality is essentially just going to be how we determine what number is going to be displayed here. So we're going to set a variable called int danger count. We're going to set it to 0. Okay. Then we're going to do something similar to how we did in our other if statement. So we're going to check to see where our actual cell is. So if game.grid size, if position is less than that, so that it checks for if it's in the first row. If position is greater than or equal to game.grid size. Times game.grid size minus 1. Okay. And I like to put this around parentheses like this. Then we're going to have functionality for the leftmost column. So that'll be if, else if, position modulo game.grid size is equal to 0. And then lastly, or second to last, we're going to say else if position modulo game dot grid size is equal to game dot grid size minus 1. And then we're going to just have a catch-all for the rest of the cells. Okay. Now we're just going to check to see if the cell that's adjacent. So we're going to first say if position modulo game.grid size is equal to 0. So this is good. This is going to check to see if it's in the top left corner. We're going to have else if that's checking for the top right corner. This is going to check for everything. Oh, wrong bracket. It's going to check for everything on just the top corner, on the top edge. All right, now we're just going to say if grid.cell grid.get. All right, position plus game dot grid size dot get type. Now we're going to see if the type of this cell that's on the top of the cell that we're looking at, if it's equal to 1, meaning that if it's a mine, then we're just going to increment our danger count plus plus. We're going to do this for the other two cells that are adjacent to the top corner. So we're going to say if this, and then we're going to add 1 right here, or no, right here, plus 1. So that's going to be to the bottom right. And then we're going to say minus right here, or no, sorry, we're just going to take that one to the right like that. Okay. Similar behavior for this right here, except we're just going to change this to a minus and this to a minus as well. And then let's take the whole thing here, put it right there. If, and then we're going to check for the 5 cells that are adjacent to the top row cells. So if position game.grid size, good. If position plus game.grid size plus 1, that's good. We're going to duplicate this and check for the other side. So we're going to set that to minus 1, and then duplicate this and set that to minus 1 as well. Okay. Then for the next side, we're going to do the same thing. So let's copy this whole thing, whole block, and we can put it right here. And then we're going to change again around this like we did for the other thing. So set this to minus, this to minus, this to minus, to minus. And then for our if statements for this one, this is going to be again for the top or for the leftmost column. And for this, we're just going to say minus game.grid size, that's good. Then we're going to have plus game.grid size and take this off. We're going to say minus grid size plus 1. Plus grid size plus 1. And then take this off. Copy this and paste it to the next side. And then we're going to change these two minuses right here. Okay, and then we're going to add functionality for all the other cells right here. So we're going to say minus dot get type plus dot get type. We're going to copy these two and set these two to minus minus and plus plus. Everything else can stay. And then we're going to set our text of the string. So cell.set text to the string dot value of. So it's going to convert the value of the integer here to a string, and we're going to set the parameter to danger count. So essentially, it's going to go through every cell that's adjacent to the number cell, and it's going to see if or how many dangerous mines that are close by. Is going to increment every time it detects one, right? We have all the if statements, and then at the end of going through all of these, it's going to set the text of the string to whatever our danger count value is. And then the easiest of them all is the mine cell. So we're going to say for int x equals 0. Essentially, what we're going to just do is we're going to disable all of our cells. While x is less than grid dot cell grid dot size. Let me just look over here. So we're going to set our text we're going to set it to be blank right now for the time being. We're going to set everything to be blank. So there will be no text inside of that cell, outside of any of the cells. And we're also going to disable all of the cells. So we're going to say sysgrid.cellgrid.getX .set enabled. We're going to set it to false. Then we're going to say if grid.cell grid.getX.get type. So if it's a mine, meaning if get type is equal to 1, then what we're going to do is we're going to say grid.cell grid.get x.set text. We're just going to set it to x. So it's essentially just going to mark out where all of the cells are. Okay, so if the cell that we're going to, essentially what we're doing is we're iterating through every cell that's in the cell grid. If it is a mine cell, which is going to be caught by this if statement, we're going to set that to an x. And then for the cell that we actually clicked on, which is just going to be cell, we're going to set the text to something like an asterisk. So we know that that's the actual cell that we clicked on that had the mine on it. Okay? That, for the most part, is going to wrap it up for our handler class. In the next section, we're going to tie everything together. We're going to add a little bit of extra functionality, like the flags, and just tidy up the rest of the classes that are left here. Thank you guys for watching, and until next time, this has been Steam Code. Please like, share, and subscribe, and if you have any questions, feel free to leave them in the comments below. Thank you.